An effective method for teaching students to design experiments begins with concrete investigations of phenomena that enable students to quickly manipulate materials and see the results. By observing and discussing these interactions, students developed an intuitive understanding of experimental design that can be formalized through effective teacher questioning and class discussion. However, students will not master the basic concepts of experimental design from one or two investigations. Repeated experiences with varied phenomena over time are necessary. Therefore, I'm going to include few investigations in this presentation. The first investigation was done with an electromagnetic system made from a battery and wire wrapped around a nail. Different sizes of nails were used. The number of paper clips the electromagnetic could pick up was measured. After formulating hypotheses, the students have to identify the independent variable, size of nails, the dependent variable, number of paper clips picked, the control variable, the battery, wire, and type of nail. The second experiment is to design an investigation to test the hypothesis. The greater the amount of salt in a salt and water mixture, the higher will an egg float. Students identify the variables, the IV, the DV, and the control. They have to answer the following questions. What variable was purposely changed? What variable responded? Is there a control in the experiment? What factors remained the same in the experiment? How could they improve the experiment? They have to make a complete list of everything they will use in the experiment. They also have to tell how many and how much of each object used and remind them to use the metric measurements only. Students have to write step-by-step directions on how to do the experiment, not to leave anything out. They have to perform their investigation with at least 3 trials and display data using charts, tables, or graphs. Students have to write a few sentences how their experiment turned out. As conclusion, students have to write why they think their experiment turned out that way it did. They have to include if hypothesis was or wasn't supported. Even when their hypothesis was not supported, they gain information about the topic. One more investigation, the same way could be done in designing an investigation to test the hypothesis. The farther a ball drops, the higher it will bounce. Now let's think about it. In this lesson, students were exposed to different forms of assessment. In the first slide, they were made to recall their previous learning on the 3 types of variables. This knowledge was then used to have them identify the variables present in a situation. As another situation was presented, students were able to practice their skills in identifying variables. Then they were presented with a new situation where they will design their own investigation to test the hypothesis. They used their previous knowledge and skills in designing and conducting an investigation. They were also given opportunities to reflect on how their scientific study went well by describing the results and drawing conclusion. This whole lesson exposes the students to multiple forms of assessment and formative and summative. The summative assessment being the performance task where they actually apply their learned knowledge and skills into a new but relevant situation. Furthermore, reflection brings them deeper cognitive process called metacognition. This is necessary to help students see the purpose of the work they have to do, to consider strategies, and to monitor their success.